As I was saying, there are other methods of heat transfer other than convection and conduction. The third method is known as radiation. Radiation. Radiation transfer heat through electromagnetic emission. Emission. Uh, this is independent of medium, and we know that temperature is the kinetic energy of all the mean kinetic energy of the vibration, and radiation is generally quantified in terms of wavelength for all objects. The basic equation of wavelength is velocity is defined as wavelength time frequency. Okay, so thermal radiation. So thermal radiation occurs when the wavelength lie from 10 to the power minus 7 to 10 to the power minus 4 meter. So this range of wavelength will give us thermal radiation, and this occurs only for bodies whose temperature is above absolute zero. So absolute zero. Uh, Also, this is a volumetric phenomena, and radiation occurs due to temperatures only. Okay, so there are different laws of radiation which governs, as we have seen, the Newton's law and uh, Fourier's law. There are different laws that governs radiation phenomena. But before that, we need to consider the concept of black body. Black body. So before understanding the black body, we have a body. We have to consider a body where emission is heating. Not emission. Let's say a heat is entering at Q. Total heat is Q. Some of the heat are getting reflected. Some of the heat are getting through and observed in the body, and some of the heat are transmitted through the body. So we get here Q equals to QR plus QA plus QT. uh, if I say quantify the total heat BE1, I'll have to quantify this with Q. This is this, and transmittivity with this. So these sorry these all are quantified as, this is known as reflectivity. Okay, so what is the reflectivity? uh, Only, and this absorptivity is defined by alpha, this transmittivity is defined by tau. So this, the sum of all reflectivity, absorptivity, and transmissivity is 1. So for a perfect black body, we have uh, and this is the first process. We know that after this is removed, some of the heat is absorbed in this body as QA. Okay, so, and what we isolate the body, it will emit some radiation, and that is quantified as emissivity, E. Eta. Here, for a black body, uh, for a black body, we have our emissivity is 1, our absorptivity 1. It will absorb all the body, but it won't reflect any, and it won't transmit any. So this is our black body. So there are other kinds of bodies quantified as white body. What is a white body? White body is that kind of body whose reflectivity is 1, which does not let any kind of heat or thermal radiation enter it. So other are 0. What are others? If this is uh, our reflectivity, then our absorptivity, our transmissivity, and our emissivity all are 0. Other body is gray body. Gray body is the body where the relative property of the body remain constant and uniform throughout the entire wavelength. Okay, so what I just said that the relative property remain constant. What are the relative properties? These are reflectivity, absorptivity, transmissivity, and emissivity of they remain constant. So, what is an opaque body? Opaque is some body which does not transmit. And if we put this zero in this equation, we'll get reflectivity plus absorptivity 1, and our emissivity lies between 0 to 1. Okay, so these all are about the bodies, absorptivity, reflectivity, and transmittivity, as well as emissivity. Mm, we are talking about laws. What are different laws? What is a black body? Black body is a perfect emitter and perfect absorber, and it absorbs all regardless of wavelength and regardless of direction. Whoever comes, whenever comes, it absorbs all. So we will be looking at Planck's law first. Planck's law, I will be writing only statements here. It states that its statement of the Planck law is EB equals to C1 lambda power minus 5 times E power C2H lambda KT minus 1. This is our Planck's law, where our C1 and C2 has constants and 3.72 10 to the power minus 8, and C2 is 1.44 into 10 to the power 4. Okay, this is our Planck's law. Wien's displacement law, or simply Wien's law, displacement law. Uh, the ratio, okay, so it signifies that the maximum wavelength and temperature is a constant value, which is 0.0029 Kelvin. Okay, what does it signify? It signifies that maximum wavelength occurs at a certain temperature, uh, and this is always constant for a body. This is generally uh, created if we do this, the calculus, and if we take the EB with respect to lambda is equals to 0 from this law, we get the value of lambda, which is our lambda max. So how to get the max value of this? If we say mathematically, we'll differentiate this equation, or simply Planck's law. And what it will get us? It will get us, if we differentiate, C1 lambda t equals to C2 lambda t. This is wind displacement law. Lambda max t equals to constant 0.029 mk. Third is our Stefan Boltzmann law. Stefan Boltzmann law. It states that EB is equals to lambda T4. That emissive power of a body is directly proportional to, of a black body is directly proportional to fourth power of temperature. And if I do this, the rate of power, it will create a Stephen Boltzmann constant, corresponding area and temperature, where Stephen Boltzmann constant is 5.67 into 10 to the power minus 8, 5.67 5678 minus 8 Weber per meter square Kelvin, meter square Kelvin. Fourth law is Kirchhoff's law, which states that emissivity is equals to absorptivity. Emissivity is equals to absorptivity for a black body. Okay, so how do we do this? So there is a proof, and I'm not going to do this right now. So we will have to remember that E equals to lambda for Kirchhoff's law. Now, what is emissivity? We'll talk about emissivity a little bit. For a black body radiation, for an opaque body radiation surface, okay, emissivity is E. This symbol, which is the ratio of emitted by the surface to emitted by the perfect black body at same temperature. If we have two different bodies of same surface area, then the total emissive power emitted by the surface to the total emissive power emitted by the perfect black body is known as emissivity. It is a measure of how closely our body, our surface, resembles black body. So if emissivity is 1, we can say that it is a black body. So I think we have completed the second part of heat transfer.